guys, so today we're going to be reviewing Module 16, the basic ideas of perception and sensation. Okay, so how do we create a meaning of the blizzard of sensory detail, right? Like how do you process all that information, right? So basically what it means is, for example, if you are with a friend and you see them walking, how do you recognize them? How do you take a picture of them and say, oh, that's my friend, I recognize that face? Well, in this case, that's a perfect example of the idea of connecting both sensation and perception. Okay, so you must be wondering, what are sensations, right? So sensations are the processes by which our sensory receptors and nervous systems receive and represent stimulus energies from our environment. Sensory receptors are the nerves that respond to our stimuli. Okay, so you may be saying, like, what about this, right? So sensation is the bottom-up process by which our senses, like vision, hearing, and smell, receive and relay outside the stimulus. This is very important because bottom-up processing starts at our sensory receptors and works up to higher levels of processing. Okay, so why is this so different, right? Well, perception is the top-down way our brains organize and interpret the information that's put into text. This is very important because top-down processing constructs perception from this sensory input by drawing on your experience and expectations. An example of this would be, for example, a flower. So how does this compare to a flower? Well, as your sensory brain absorbs the information, bottom-up processing enables your sensory systems to detect the lines and angles and colors of the flower. And leaves, of course. So using the top-down processing, now you're interpreting what your senses detect. Okay, so a perfect example of this is right now at this very moment, right? So you're on your phone has light. As you're watching this video of me explaining Module 16, you are receiving light, and that sensation of light and sound of me speaking is taken to your brain and processed. Now, perception, on the other hand, it's not processing what you're feeling, what you're receiving, but instead what you're learning, what you're trying to understand. Every second of the day, we're being bombarded with different types of stimuli, different things for our mind to process. Smell, sound, waves, radioactive waves, radio waves, sound waves, everything that's coming to you and you're not necessarily like trying to process it. It is a stimuli. Sensory things, you most of the time cannot see them. When in perception, what I'm saying is that you're looking at me and you're trying to understand something, right? That's perception. Now in sensory, you're not necessarily seeing the sound, you're not necessarily seeing the light. So that's the main difference of how it may look. Let's say you're with your puppy, right? So you have it with you and you're trying to look at it, smell at it. So you look at it and you're like, oh, it's fluffy, and then you're like being enchanted by your dog, right? But you cannot, that's getting a perception. Now, getting the sensory details, well, that's different. Because, for example, you're saying, oh, you can smell the dog, and then you can see different things, but you cannot get the sound wave, you cannot see the sound waves that are coming out from your dog when it barks. Okay, so like everything, there are thresholds to this, right? So one example of this is the idea that I explained before of you're not being able to see the sensory details. And another idea is the idea of animals. Not everyone has to perceive the same sensations, So, for example, different animals have different needs. So they smell different things, they want to see different things. Okay, so the other way that you can think of a threshold is the minimum stimulation necessary to detect a particular light, sound, pressure, taste, or odor 50% of the time. Okay, so what are different thresholds? So to function the way that we have to function, we need the absolute thresholds low enough to allow us to detect important sights, sounds, textures, tastes, and smells. We also need to detect small differences among stimuli. A musician, for example, must detect minute discrepancies when turning on an instrument. This is very important. That way when they're singing. That way when they're playing their instrument, they know what's wrong and what they need to fix, right? So another thing is parents, they must detect the sound of their own child's voice and emit other children's voices. This is very important. Let's say your kid's running around and then someone starts crying. You have to know how your kid cries. That way you know if you have to go over there or maybe you don't. For example, personally, I'm used to hearing my brother's voice, right? So whenever we're in this party with kids, of course, right now, no, because we're in COVID. But before, when there was parties, and I would hear someone cry, I would be like, that's my brother. Because he has a certain way of crying, and I am used to detecting the way that he cries. The exact definition of a difference threshold is the minimum difference between the two stimuli required for detection of 50% of the time. We experience the difference threshold as just a noticeable difference. For example, I cannot differentiate my brother's voice if someone else is not there. Like, what do I mean with this? For example, if everyone's voices sounded the same way, you wouldn't be able to detect a certain person. But since all our voices sound different ways, we cry in different ways, we are able to detect people's sounds. Okay, so how does this go back into the idea of processing perception and sensations? Well, you are receiving, let's go back to the idea of the kid crying. So you are receiving the sensation of sound, and then you start processing it, and you start perceiving the voice of the person that you know. You start recognizing it. It's like on the first example that I showed you where I was talking about friends. If they're walking, you're getting the sensation of sight and sound. If they're stepping, you're hearing the sound of their shoes. And then if you're looking at them, you're getting sight. But how do you so you start getting that stimuli, but then you start perceiving, getting perceptions and analyzing their faces. Okay, yeah, that's my friend. Okay, so how do you get the signal detection, right? How do you process things? So when reading mammograms, for example, a health professional needs to seek and detect presence of faint cancer stimulus in background stimulation, and all of this without raising false alarms. So they do this by using new 3D ultrasound breast imaging technologies where they can clarify the signal and reduce the rate of false alarms. Okay, so going back to the idea of differentiating things, we still refer back to Weber's law. For example, an average person to perceive a difference, two stimuli must differ by a constant minimum percentage. What does this mean? So to be exact, percentages varies. Depending on stimuli, two lights, for example, must differ in intensity by 8%, two objects must differ in weight by 2%, and two tones must differ in frequency by only 0.3%. This is very important. Why? Well, because of course, if you see two colors, two blacks, and they're so similar, the only way that you can differentiate them is if they have a differentiate of 0.3, right? Okay, so that will be it for Module 16. I hope you guys understood, and well, I hope to see you next time. Bye-bye.